Hybridization is a very important topic in the AP chemistry and also in chemistry. Okay, now when it comes to AP chemistry, we only have three possible hybridizations, which are going to be SP, SP2, and also SP3. Now, this can be confusing for people because they would not know, when is each hybridization utilized. So I go by the term thing. So if you see two things, that would be SP, three things, SP2, four things, SP3. Now, what's a thing? It could be a lone pair, it could be a bond, whether single, double, or triple. So a single bond and a double bond and a triple bond would all be, treated as one thing. Let's give you some examples. Let's talk about CO2. So drawing the Lewis diagram is going to be very, very important for AP chemistry and most chemistry courses. So CO2 is going to look like this. Okay. And let's just put the dots on the O's. So how many things do we see on the carbon? Well, by thing, I mean a lone pair or a bond. So I see one double bond and I see another double bond. So essentially, I see two things. And if I see two things, that would be SP. Okay, that would be SP. Let's do another one. Let's do CH4. Here I see four things on the carbon. 1, 2, 3, 4. So four things would be an SP3. Let's do BCl3. Here I see three things on the B. 1, 2, 3. That would be SP2. Let's do ammonia. So that would be NH3. Here I see four things. I see 1, 2, 3, and 4. That would be an SP3. Okay, so in AP chemistry, we can have hybridizations ranging from SP to SP2 to SP3. Only three possible hybridizations are allowed. Now, how about the angle? So, the angle is going to be 180 degrees for linear geometry, which is basically things with an SP hybridization. So, CO2, we talked about. We can also talk about BeCl2. Which would look like this, Be with two Cl's. Let's put the dots. And here we have two things, 1 and 2. That would be SP. So SP hybridization would be 180 degrees. SP2 could be either 120 or a bit less than 120. Let's talk about those things. Let's clear up the space. So when is it 120 for trigonal planar, which would be something like a BCl3? Put the dots. So here I see 1, 2, and 3. That's why it's SP2. And the shape is going to be trigonal planar. But how about less than 120 degrees? That would be for bent of SO2, which would look like this. So here we have 1, 2, and 3. That's going to be SP2. And here it's going to be bent, with the angle being slightly less than 120 degrees, whereas the angle here for trigonal planar is going to be 120 degrees. Four things would be SP3, ranging from 104 to 105. So, for example, if I'm talking about a CCl4 with dots on the Cl, well, that would be essentially, here we have 1, 2, 3, 4. That's basically four things, which means SP3 hybridization the geometry is going to be tetrahedral, and the angle is going to be 109.5 degrees. But if I am discussing water, which has a bent geometry, but still it has 1, 2, 3, 4. So still is going to be sp3 hybridization. Water is going to be bent geometry, which basically will have 104.5 degrees. So as you can see here, we have bent for water, and we have also bent for the SO2, but they come at different angles. SO2 being slightly less than 120 degrees, while the water being 104.5 degrees. So why is that the case? Because in the case of SO2, there is only one lone pair on the S, but in the case of water, we're going to be having two lone pairs on the O, which would decrease the angle. Okay, and that's about it for hybridization and the bond angles that correspond to them.